We are covering 13.3 notes on page 864. This is just probability. Most of this you're going to be really good with. There's a couple new vocabulary words, okay? The set of all possible outcomes is called a sample space. We've talked about that from one of the packets last week. So for example, if you're flipping a coin, the sample space is heads or tails. If you're rolling a die, the sample space is 1, 2, 3, 4, 5, 6. You have to list all of the choices, okay? It is simply a list. An event is any outcome or set of outcomes in the sample space. For example, in the experiment of rolling a number cube, the set 1, 3, 5 is an event, which would be read rolling a 1, 3, or 5, or rolling an odd number. Probability can be anywhere between 0 and 1. And this is the line you need to know. The sum of the probabilities of all of the outcomes in the sample space is 1. So in other words, if you're rolling a die, the probability of getting a 1 plus the probability of getting a 2 plus the probability of getting a 3 plus the probability of getting a 4 plus the probability of getting a 5 plus the probability of getting a 6 has to total 1. Does that make sense? Because those are the 6 ways it could happen. Okay. The probability of an event is the sum of the probabilities of the outcomes in the event. In other words, if you wanted to roll an odd number on a die, you'd add up the probability of getting a 1 plus a 3 plus a 5, which would be 3, 6, or 1/2. Okay, moving on. Probability distribution is when you just set up a little table, okay, and you list all the outcomes and their probabilities. So suppose there are 100 marbles placed in a bag, 50 red, 30 blue, and 10 yellow, and 10 green. What is the sample space? 50 red, 30 blue, 10 yellow, 10 green. Okay, you would just list them. Okay? Write out a reasonable probability distribution. Okay, there were, I already forgot, red, blue, yellow, and green.
Yeah.
Okay. There were
50 red.
50 red out of 100. So what's the probability of getting red? So you would say 1/2, or 50 out of 100. Blue was 30 out of 100, or 3/10, and the other two were both 10 out of 100, or 1/10. This little chart is called a probability distribution, and do they all add up to 1? 5/10 plus 3/10 plus 1/10 plus 1/10 is 10/10, right? All right, so there is a probability distribution. Anybody have a question about what that would look like? Just a little chart with all the probabilities possible. What is the probability that a blue or green marble will be drawn? Yes, there's a total of 40 blue and green marbles divided by 100. Or 4/10, which would be 2/5. You could have also added the probability of a blue plus the probability of a green to get 0.4, or 2/5. And I don't care if you do decimal, fraction, or percent for the form of your answer. Any questions? Okay, probabilities expressed as percents are often called chances. So you say 50% chance of drawing a red marble, etc. All right, we need to understand this vocabulary. Mutually exclusive. 2 events are mutually exclusive if they have no outcomes in common. If 2 events are mutually exclusive, then the probability of the event E or F is the sum of the probabilities of E plus F. Okay, drawing a red marble and drawing a blue marble, there's no overlap. So it was the probability of red plus the probability of blue, or something like that. I don't remember what colors there was. The complement of an event is the set of all outcomes that are not contained in the event. In other words, what is the probability of not drawing a red is 1 minus the probability of drawing a red. Does that seem to make sense? We've talked about complement before. Everybody have down what they want from that page, or not quite? If it's an or and they're mutually exclusive, yes, you just add their probabilities together. It says, which of the following pairs of events, E and F, are mutually exclusive? An experiment consisted of spinning the spinner. The following table shows the probability distribution, because it's a goofy way that this spinner is made, okay? Are these mutually exclusive? E and F, is there any overlap between this E and this F right here? Yeah. So these are not mutually exclusive because the letter C is in both. A vowel and the first 5 letters of the alphabet.
Yes, it's not mutual.
Okay, those have overlap as well. A and E are in the first 5 letters of the alphabet, right? And they're both vowels. A vowel and the letter C. There is no overlap, so these are mutually exclusive. Okay? No overlap means mutually exclusive. What is the complement of the event A or S? All right, this means 1 minus the probability of getting an A or an S, which would mean you had to get a C or an E, which would be 0.3. They don't even ask the probability. They just ask what is the complement of the event, okay? The complement of the event A or S is simply the event C or E. All right. C, what is the probability of the event the spinner does not land on A? So you could add these up, or you could do 1 minus 0.4, right? To find the probability that the spinner does not land on A. Everybody okay? All right, independent events. 2 events are independent if the occurrence or non-occurrence of one has no effect on the probability of the other. For example, an experiment is repeated several times under exactly the same conditions. The outcomes of the individual trials are independent. If 2 events are independent, then the probability of the event with an and is the product of the 2 separate probabilities. We did this last week when we said, like, if you roll, what's the chance I roll a tails? I flip a tail and I roll and get a 6. It's 1 out of 12, if I could write. Okay, 2 totally independent events. So this is probability of tails times probability of rolling a 6. So the probability that you get tails and a 6 is 1/12. Those are independent events. Here's a little chart, okay? It says mutually exclusive usually refers to a single trial of a given experiment. It usually has the word or, and you add. Independent events refers to 2 or more trials of an experiment or from different experiments. It will have the word and you multiply. This chart is on page 868. If you have 868, if I could write. If you have any trouble, you can refer to that, okay? All right, probability of winning a certain game is 0.1. Suppose the game is played on 2 different occasions. What is the probability of winning both times? Independent events, right? So the first time your chance of winning is 0.1, and the second time your chance of winning is 0.1, which is 1/10 times 1/10, guys.
0.1. Oh.
1/100th, okay? What is the chance that you lose? Which is? Okay. What is the chance that you win once and lose once?
0.1
No, this is 2 totally different events, okay? You could win or lose on the first try, then you could win or lose on the second try. So the chance that you win is 0.01. The chance that you lose is 0.81. But there's 2 ways you could win once and lose once. I need the total of these 2. How do I find that?
I would just take the rest.
That'd be the easiest way. The chance that I lose both times is 0.81, and that I win both times is this. So the remainder is
0.12. Right?
0.82. Is it 0.18? Okay. The other way you could have done that is to say I'm going to lose the first time and win the second. Win and then lose, or I'm going to lose and then win. But you have to add those together, because you have to say, what's the chance that I win once and lose once? Well, I could win the first time and lose the second, or I could lose the first and win the second, so the possibility is 0.18. Yes? No? We kind of get it? It's a little complicated. It's because they're not even. You can't just write win, win, lose, lose, okay? All right. A random variable. You need to understand this term, and students have a really hard time with this. Don't make it too complicated. It says the characterization of experiment is often numerical, but sometimes it's not. For example, heads and tails. You can assign a random variable to each outcome. So if you decide heads were going to be 1 and tails were going to be 0, then the sample space would be 0 or 1. Okay, an experiment consists of rolling 2 number cubes. A random variable is assigned to each outcome for the total of the faces shown. What are the total of all the dice? Ways that 2 die can total up. Okay, so if you had to write out the whole sample space, you would have a 1 and a 1, a 1 and a 2, a 1 and a 3. You could go down this way, a 2 and a 1, 2 and a 2, 3 and a 1, 4 and a 1, 1 and a 4, blah, blah, blah. You'd list them all. It would look like this. This is the total sample space for 2 dice rolling. Okay? It says, what is the range of the random variable? This is where students get totally lost. What are they talking about? We want to find the total of the sum on the die. So what are the range of values we can get for the total of the number of pips or dots showing? Can we get for 2 dice, the sum of 2 dice? Can you get a 1 when you roll 2 dice? Yes. The 2 dice, the number of dots showing, can total anywhere from 2 to 12. Does everybody get that? because it was asking for a total here, okay? Range is a set of integers from 2 to 12. List the outcomes to which the assigned value 7 is assigned. Well, you could get a 1 and a 6 or a 6 and a 1. What else could you get? Is that it? Okay. So the value of 7 is assigned to these 1, 2, 3, 4, 5, 6 different ways that you could get a 7. Okay. Random variable can be a little confusing. All right, last vocabulary, expected value. The expected value, or mean, it's also called the average of a random variable, is the average value of the outcomes. In the experiment of rolling 2 number cubes, suppose the experiment was repeated 10 times, resulting in the following values for the random variable. Okay, we got a total of 7, 8 out of 10 times, 5 out of 10, 8 out of 10, 6 out of 10. Oh no, okay, this is the total on the die for each of our 10 times we rolled them. My bad, I was not explaining that well. Okay, so the first time we rolled, the die totaled 8, and so on. Then we rolled a 5, an 8, a 6, 11, 11, 3, 9, 9, and 7. When we averaged those 10 rolls, we got a 7.7. If the experiment is repeated a large enough number of times, the average will approach what's called the expected value. All right, an expected value for dice, if we took all those, for the sum of the dice, we took all these, there's exactly one way you can get a 2, yes? But there are 2 ways that you can get a 3. Everybody okay? 3 ways you can get a 4. Everybody see that? Okay. So the chance of getting a 2 is 1 out of the 36 rolls, while getting a 3 was 2 out of 36. Getting a 4, I'm sorry, was 3 out of 36, because you could roll a 2 and a 2, or a 1 and a 3, or a 3 and a 1. Chance of getting a 5, 2 and a 3, or a 1 and a 4, and the reverse, right? So that was, again, 4 out of 36, which is 1/9. All right, you write out all those probabilities, and to find the expected value, what can you expect to roll? You have to take, I will roll a 2 1/36 of the time, and I will roll a 3 1/18 of the time. I will roll a 4 1/12 of the time, and so on. When you add all that up, it adds up to 7, so your expected value is a 7. Okay, does that mean you're going to roll a 7 every time? No. I think expected value makes more sense when you talk about something like this, okay? This is a probability distribution for winning a lottery. It's a $1 ticket, and here's your chance. The chance that you win nothing is this. Chance you win $3 is 6%. Okay, the chance you win $40 is this small. The chance you win $2,500 is this small. To find the expected value, you multiply. I don't need to write all that out because you're going to multiply it by 0, right? But then you multiply 3 times 0.06 plus 5 times 0.04 plus 10 times 0.01. And you add all those up, and it comes out to 0.71. What does that mean? It means if you play the lottery long enough, you can expect to win 71 cents over the course of all those experiments. But how much did you pay every time for a lottery ticket? $1. So there is an average actual loss of 29 cents when you play. Averaged out over, if you played it every day for a year, you would average a loss of 29 cents a day. That's what they're saying. And even a year isn't very long because it's only 365 experiments. Okay. Expected value means over a long term it would approach this value, would average out to this. All right. Is there expected value question we could, these are find the expected value. Anybody know how you're going to find an expected value there? Did anybody get expected value at all? One more time, guys. 0 times this, plus 3 times this, plus 5 times this, plus 10 times this. Everybody got it? Expected value. So how do you find the expected value on this number 17 here?
0 times 0.3 plus 1 times 0.32 plus 5 times, you get the point, yeah.
Okay?
That's a lot of work.
That's all you have to do. But it's going to be on the next quiz or test. It's going to say find the expected value. And if you don't even know what to do with all those, it's not going to be easy, right? It's not hard to find. You just have to understand what it means. And it does mean, in terms of the vocabulary, if you were to repeat this experience enough times, your average outcome would be whatever you get. All right. That's it. You need to work on the assignment, which is
Page 862.
yeah, page 862, some crazy numbers. I'll type them on this next slide if someone would read them to me, because some people aren't here.
1, 2, 5, 6,
Okay, wait a minute. Let me find empty slide. Page 862.
1, 2, 5, 6, 10 to 19. 22 to 24, 26, 27, 30, 31, 34, 35, 38 to 45, and 48.
Yikes. Okay.
Hey,
It's not even on.
don't even much wrong like that.
Yes, you may also pick up the packet, guys, that's next to the bin up there and get started working on that. Wait a minute. You just read me the assignment for page 862, which is 13.2. I just taught you 13.3.
You said 862.
That's because someone else told me that was the page. Okay, the assignment that goes with this that I just taught.
It's 872, 1 to 24.
All right, that's what you need to be doing.